section 2.5, more on graphing linear functions. Intercepts. Intercepts are values across the axis. So just a quick reminder, a rectangular coordinate system is made up of two lines. We have what's called your x-axis, and we also have what's called your y-axis. So if we have an intercept, that's a point that directly falls on your y-intercept and a point that falls exactly on your x-axis. And we can find all those points that are labeled an intercept. Let's read the definition. X-intercepts and y-intercepts. A y-intercept is a point 0, your number, say b. To find b, let x equal 0 and solve for b. X-intercept is a point a, 0, where a is your number. To find a, let y equal 0 and solve for x. And we can also use intercepts to graph. Let's do this in the example. Find the intercepts of 3x plus 2y equals 12, then graph the line. Okay, let's start off by finding our intercepts, since that's what our question is asking for. For our x-intercept, or according to our rule, our definition right above, we're going to let the other letter be 0. So let y equal 0, and then we're going to solve. So that I have 3x plus 2 times y. Instead of y, I'm going to replace it with 0 equals 12. Okay, let's go ahead and now solve for our letter. Let's solve for our letter x. So 2 times 0, that's gone. That's just 0. So we're left with 3x is equal to 12. Let's get x by itself by dividing by 3. So that is now 1. We're left with x is equal to 4. That is our x-intercept. Now we want it as a point. So our y is 0 and my x is 4. Remember, your point's always given as x, y. We found x and we let x be 0. Let's find the other intercept. So to find your y-intercept, same idea, you're going to let your other letter be 0. So this time, let x equal 0. So that we have 3, but instead of x, I'm going to write 0, so that's what we established, plus 2y is equal to 12. Well, anything times 0 is 0, so we're left with 2y is equal to 12. Divide by 2 to get y by itself. We're left with y is equal to 12 divided by 2, which is 6. So let's write our point x, y. X we said is 0, and we got a y of 6. So these are our points. So we found the intercepts. Let's go ahead and graph. So remember, the one that goes up and down is your y-axis. The one that goes to the left and right is your x-axis. Our x-intercept is the point 4, 0. So here we have it, 4, 0. And our y-intercept, the point that touches your y-axis, is not negative 6, positive 6. Here we go. Now to graph our line, well, we just need 2 lines to create 2 points to create a line. We just connect them and we have our line. This is how we graph using intercepts. Before moving forward, this is a great way to graph. The only hiccup is, what if my x-intercept and my y-intercept are both 0? I don't have any other point to use to graph. So that's the only downfall using intercepts. But other than that, it's pretty fun. Graphing using the slope and the y-intercept. We just saw how it may be possible to graph using intercepts. However, what about the situation where x and y intercepts are the point 0, 0, which is what we just talked about? So here is another way to approach graphing. This is how you graph using your slope and intercept. First, make sure your graph is in slope-intercept form, y equals mx plus b. If not, then you solve for y and make it look that way. 2. Plot the y-intercept. This point will be directly on the y-axis. 3. Use the slope as the rise and run. If the slope is not a fraction, write it with a denominator of 1. A. Count the units up or down, which are the rise. And then B. Count the units left or right, which are the run. So let's do an example. Let's graph negative 2 over 3 plus 1. Okay, so we first want to start with our rules. Our first rule says make sure it's in y equals mx plus b form. That's done. 2, plot the y-intercept. So here we have a y-intercept of 1 and a slope of negative 2 over 3. So let's plot my y-intercept of 1. And then I'm going to use my slope. Think of your slope as your rise over your run. So I have a negative 2. So rise refers to up and down. I have a negative 2, so I'm going to go down 2 from my point, and then go to a positive 3, go to the right 3. All right, so I'm going to zoom in a lot. So here's my point. My slope says go down 2, right 3. I'm going to go down 2, 1, 2, and then to the right 3. 1, 2, 3. So here is my next point. Now I have 2 points to create a line. Let me erase my little notes. And now I can go ahead and graph my line. There we go. We used your y-intercept and your slope. Now, a question you might be thinking about, because I always get this question, is where does the negative go? So for our slope, I have negative 2 over 3. Well, my entire fraction is negative. It doesn't matter if you attach the negative to the 2 or if you attach it to the 3. As long as there's one negative, it makes our entire number negative. A little side example. Say if I had negative 6 divided by 2. Well, that gives us negative 3, right? What if I had 6 divided by negative 2? It still gives us negative 3. It still gives us the same answer. So it doesn't matter if we have a negative on the top or on the bottom. As long as we just make one of them negative, it makes our entire number negative. So I always attach it to the numerator in case you want a rule to follow. Always attach it to the numerator. Let's go ahead and do B. Same idea. I want to first find my y-intercept. So let's label our y-intercept. My y-intercept is 4, and then use my slope. We have a slope of 4 over 5. I want to use your rise over run. Your rise goes up and down. Your run goes left to right. Because I have a positive 4, I'm going to move up 4. Because I have a positive 5, I'm going to move to the right 5. All right, so let's first plot our y-intercept. My y-intercept is positive 4, and then I'm going to go up 4, right 5. 1, 2, 3, 4, and then to the right 5. 1, 2, 3, 4, 5. I connect my my points to create my line. And this is how we graph using your y-intercept and your slope. Horizontal and vertical lines. Horizontal line and the vertical line. Let's go ahead and read that definition. The graph of y equals a number, or f of x equals a number, let's say that number is b, is a horizontal line, left and right, with a y-intercept at 0, comma b. It is a graph with a constant function and a slope of 0. We also have the graph of x equals a number. Let's say this number is a. This creates a vertical line, which is a line that goes up and down, with the x-intercept at a and a number, and a slope that is not defined. So your slope is undefined. This is not the graph of a function. Okay, let's do these two examples. So I want to graph y equals 4. When I have y equals a number, let me erase all those little chicken scratches. When I have y equals a number, we said that's always going to give us a horizontal line. So here I have a horizontal line at -4. So horizontal means left and right. So I have a left and right line at -4. So here's -4. There is my line. Okay, x equals 6. When I have x equals 6, I'm going to have a vertical line. So I have a vertical line at 6. So here is 6. I'm going to go up and down 6. And just to emphasize what was mentioned about slopes, a horizontal line has a slope of, that does not look like an M, a slope of 0, and a vertical line has a slope that is undefined. Moving on, parallel and perpendicular lines. Let's define parallel lines. Two non-vertical lines are parallel if they have the same slope and different y-intercepts. Vertical lines are parallel lines. Okay, so to create a parallel line, I just have to ensure that they have the same slope. So let's do the example. Determine if the graph of y minus 3x equals 1 and 3x plus 2y equals -2 are parallel. So we don't know. We have to be able to identify their slope. And they're not a situation where I can just pick out the slope. So let's take the time to solve for y so that I have y equals mx plus b. So that that way I can just pick out what that slope is. So let's take a look at that first equation. I have y minus 3x equals 1. Okay, well, to get y by itself, I just need to move the 3. Plus 3x plus 3x. We're left with y is equal to 3x plus 1. Okay, so I can say, okay, my slope of that one is 3. Let's see if the slope of my other function is also 3. Okay, for my other function, I have 3x plus 2y equals -2. Let's move the 3x over, minus 3x, minus 3x. We're left with 2y is equal to -3x minus 2y. Not 2y, why did I say 2y? Okay, lastly, get y by itself by dividing by 2. Divide by 2. We're left with y is equal to, and this 2 is dividing both terms in the numerator. And yes, I did draw a heart. That helps remember. So I have -3 over 2x minus 2 over 2 is 1. So here, my slope is -3 over 2. So no, they're not the same slope. So no, the lines are not parallel. And this is because we see their slopes are not the same. Let's do the next one. Determine if the graph of 3x minus y equals -5 and y equals 3x equals -2 are parallel. Well, let's take the time to see. So for my first equation, I have 3x minus y equals -5. Let's subtract 3x, subtract 3x. -y is equal to -3x minus 5. Let's divide by -1 to get y by itself. And we're left with y is equal to positive 3x plus 5. Okay, next one. I have y minus 3x equals -2. Let's get y by itself, plus 3x, plus 3x. We're left with y equals 3x minus 2. All right, take a look at our slopes. I have a slope of 3 and a slope of 3. They have the same slope. So we can say yes, the lines are parallel. Perpendicular lines. Two lines are perpendicular if the product of their slopes is -1. So I'm going to have a number times another number, and my answer should be -1. We tend to have fractions. If one line has a slope of m, then the slope of a line perpendicular to it is -1 over m. That is, to find the slope of a line perpendicular to a given line, we take the reciprocal, which is just the flip, of the given slope and change its sign. So if it's positive, change it to negative, and if it's negative, change it to positive. The lines are also perpendicular if one of them is vertical and the other one is horizontal. So be careful for that. So determine whether graphs of 5y minus 4x plus 10 and 4y minus 5x plus 4 are perpendicular. So because we're looking for perpendicular, we want to identify their slopes, find out what their slopes are, and they should be opposites, meaning one is positive, the other one's negative, and reciprocals, meaning the same numbers, but they're going to be flipped. Okay, I don't know what slopes we have, so let's figure that out. So for our first one, we have 5y is equal to 4x plus 10. Let's solve for y. So let's divide by 5, and we're left with y is equal to 4 over 5x plus 10 divided by 5, 2. Okay, so my slope here is 4 over 5. What should my other slope be? So I don't know what it is, but whatever it is, it should be, for it to be perpendicular, it has to be a negative and a 5 over 4. So this is our goal if we want to say, hey, yes, these two graphs are perpendicular. Let's do our work. So let's take a look at our other equation and find the slope. So I have 4y is equal to negative 5x plus 4. I want to get y by itself. Let's divide by 4. So we're left with y is equal to 5 over 4. We have negative 5 over 4x. And 4 divided by 4 is 1. Is it negative 5 over 4? Yeah. So we can say, yes, these graphs are perpendicular. Perpendicular. Okay, thank you. This was section 2.5, more on graphing linear functions.